Okay, all yours.
Well,
Okay.
thanks, Mati. Hello, I'm Alfonso. I'm part of the research team here in Learning Labs. Today we are going to be talking with Mariana, which is also part of the research team, about the 3 visualizations that we have built in this time for the research team. How we arrive at the idea, then how we iterated the idea to get to the design that we finally shipped, and then how we implemented this in code after the design was ready, so that you can explore it on the web. Right? That's the idea. First, a little bit about the research team. The research team was born, I believe, at the beginning of this year, because, or maybe later last year, because I have been working on dim sum for the majority of the last 2 years, and I was a little bit not bored per se of that, but I needed new things to do, and my focus was visualization, so I wanted to do something with that. I asked Yago and the leads if I could have a team to do that, because me alone wasn't going to be able to do it, because I don't know anything about design. If you asked me how to do something, I will probably put 3 squares and that's it. So Mariana was on board, and she has helped a lot on the design side of things. So yeah, Mariana is going to talk now about the first project that we had, the vaccinations project, and how we built the visualization that you can see now on research.learninglabs.
Yes. Do I continue?
Yes, please.
Okay. Today we will be showing you 3 examples of the first projects we created with the Learning research team. So let me share my screen. Also, if Aus and Alex are around, they were part of the first iterations of the first graphics, so of the first project. So if there's something that we are missing, you can interrupt us. So okay. The first project was about vaccination. We wanted to show, at the beginning, we wanted to show promises vaccines per country. We didn't know exactly how we were going to show this, or what was the differentiation that we wanted to show in this visualization. So, but we did have some resources that were super complete. So at the beginning, Alfonso created this scatter plot, and we started to do some visual research. On my side, I was supposed to look how we could show this in a visual way that was a little bit more attractive than the usual visualizations. So we found this idea of showing it with vaccines. Each vaccines will, as per the population get vaccine, this syringe will be empty. So, but that was the point when we realized that maybe the things that we wanted to show was not easy to show, because, for example, we didn't know exactly how many promises vaccines each country had. It wasn't super accurate. And then we realized this. The population this is the 100% population, sorry. And these were the promises vaccines that each country had. So it was not going to be possible to make it like super balanced graphic. And also, as I said before, we didn't have the exactly amount of promised vaccines per country. So we were talking about vaccines that didn't even exist or weren't even delivered or paid. So we switched to a more basic visualization that was about to how many people was vaccinated in each country. And we started explorations, different ways of showing this, like vertical with labels per continent, dark mode, colors. Let me know, Alfonso, if I'm missing anything. But then
you're doing great. You're doing great.
Okay, then we reached to this one because at the beginning, if we didn't realize that if the syringe was empty, we lost the legend of the color. So then we switched it to this side. So we started working with this graphic. We exported this graphic to SVG and moved it to the code. And from there, Alfonso started his explorations with the code, and then we begin a back and forth with the graphics and the code, because at the end, he only needed one syringe and the huge viewport, but then the idea scaled in the code and with infinite, well, many more possibilities that he found. So I'm not sure if you want to share your screen now with all the filters that we added and all that you did in the code.
Yes, I'm going to share my screen now. Okay, so yeah. So this is the code for the syringe itself. Well, it's a little bit big. Let me know if you can see it at that resolution, at that font size.
Yeah, it's fine.
Yeah? Perfect.
It's fine.
Okay. So basically, the syringe was exported from the Photoshop. I don't know what do you use actually, but from that file we exported it to an SVG, and we created this with, well, this is styled components. So I'm not using any SVG actual syntax, but that's the same. As you can see here, we have the paths for the each of the parts of the syringe, and we have a lot of parts. Like there are 7 parts, and there are some more on below. But the idea is that we needed to create the syringe with different parts because we use different colors, and then we have this get path here, which is the one that is actually moving, right? The other parts of the syringe are actually fixed, and this is the only part moving. And we didn't actually need a scale because we were passing a percentage value, and we knew the length of the syringe. So the only calculation that we need was this thing, value multiplied by length. With that, we created this path. I don't know if you are familiar with the SVG path syntax, but basically this is a move, this is our horizontal line, and this is a vertical line. This thing says, okay, go to the beginning. So that's the idea. So basically, this goes to the end of the syringe and starts drawing the animated part, which is actually the blue part on the syringe. I don't know why I didn't have the page open. So basically, this is the part that is animated. This thing here, not this thing. Okay. So all of the syringe had the color in the background, and this was on top of that. Well, being animated to. That's why I thought that I said that the syringe starts at the end and then it goes like here, like this. Okay. So that's for the syringe part. We had an animation prop that told the syringe if we needed to animate it or just jump to the other side, because when we had multiple syringe, like more than 40 syringe, there was a bit of a lag in there. So we wanted to not animate, but that's it. But basically, that's it for the syringe code. It's not that complex. Then we have the actual vaccination page, which would be the controller that goes from here to here. What we did here was that, well, we created all of these pieces of the state. So as you can see here, we have interesting countries, more countries. Basically, the more countries is all of the countries, and the interesting countries is a subset that we selected based on a New York Post, I think, article. And then we have some of the states. So this data index is the one that tells the syringes, the multiple ones, in which day we are. So we're on day 1, day 2, and basically it's the one tasked with the animation. So if I change to 1 to 2, it will animate. Then we have the color mapper, which at the beginning we had this thing here with colors. At the beginning we wanted to change this based on a select, but after many iterations, we scrapped that idea because it added a layer of complexity that we didn't want, so we removed that. And then we have this data name, which is the one that basically says if we are using fully vaccinated data or only one dose data. I want to also point out that because this is research, we wanted to gather some type of data for this thing. So we have this here, this log events function that we are calling, and what this does is that it sends the event to the Google Analytics backend, and with that we expect to do some kind of actual research besides the research that we do to build these things, but also to like see if the users are pressing all buttons or something like that, right? So we have a lot of events in this one, like press play, change date, change data, the change countries, because here you can select other countries also. So we have all of the countries that were available on the ongoing data repository. I'm going to talk a little bit about this, how we ended up getting the data. Basically, we went to the ongoing data repository and downloaded the CSV. Then we did this. Where is it? Well, basically, here, I got the initial date to where the vaccine started to roll out, basically. So to not have dates here that were previous to that, because basically the date would advance and nothing would happen, and I didn't want that. Then I created a dictionary, which is basically a JSON that had all of the countries that they have data that their vaccinations were rolling out. So the idea was I didn't want countries that were going to stay at 0 all of the time. And then, well, this function is get the countries that differ from, if we added some countries versus the last time we ran this code, because, well, I had to run this code manually. Now Marcos, another teammate of the research team, is automating this. So these are all of the countries that changed between the last time I ran and the next time I ran this. When we launched it, we had 70 countries, and now we have 110, and I guess that Marcos will tell us that we have 130 now, but I don't know. And basically with that, we built the JSON that powers this, which is 1 entry per day per country. And that's the idea here. That decision was made in order to animate it easy. That's it for this project. Mariana, your turn.
Yeah, I remember that there was, I don't know if it was a bug with the animations that Mati and JC helped
Oh,
us
yeah.
with that at the end. I think
Yes.
it was an overload of vaccines in one of the pages.
Actually, I think it was only on my computer. I don't know why, but basically the idea was that, or the problem was that these animations were beginning at the bottom of the page and animated from here to a place here. And after some catch, reload, or something like that, it disappeared. But it was only on my PC, and JC didn't have problems. Anyone else didn't have problems. So at the end, we just launched it like that, and nobody reported the problems.
Yeah.
Mm-hmm.
You want me to share my screen?
Yes, your turn again.
Okay. So, the Day of Human Spaceflight, International Day of Human Spaceflight. As we wanted to have, sometimes ideas they don't appear like every day. So to have a motivation, we wanted to see which special events will happen in the world, like calendar events. So each month we review all the days that they are celebrating internationally. And we found this International Human Space Flight that was on April. So it was like the motivation to start working in something new and have a deadline and see how we could solve it with whatever we had at the time. So we had this idea was like pretty straightforward in the meaning that we knew from the beginning which library we were going to use to do the animation. We have some references that we saw on our weekly talks. So the graphic in this case was like simple in a way that we wanted to get all the planets aligned, and then the animation will make a storytelling, like zooming in and out and telling a story along the way. That Alfonso will show it at the end. But this was like a different approach. At the beginning, we started more with the illustrations and then see what we could find or what thing was interesting to show or how to show it with a visual interesting, like the beginning. I mean, how can I tell it? Like the starting point was the illustration. In this case, I think that the starting point was most the way of telling the story and the library that we would use it at the end with this. So it was a completely different approach. But at the same time, we created this with SVG and then exported each of the planets in one SVG. But we do have the viewport and the view box here, and then we started positioning everything in the line separately. Yeah, so I think that I can send you can share your screen again, Alfonso, to show the final result of this.
Okay. So this is the final result of that visualization. I expect that you all saw this. If not, then you can leave the talk. No, that just can just stay here and see what you missed. So the idea here was, as Mariana was telling, that to tell a story about the human spaceflight. So on April 12th, Yuri Gagarin was the first man in space, and we wanted to tell the story about the human spaceflight. So we have this. This is Yuri Gagarin. He flew to 327 kilometers outside Earth. I don't know if it's outside Earth or from the beginning of the ocean, but let's stay with that. And the idea here is that nice, Jerry, that we had this animation here that is showing how the human spaceflight was advancing day to day, right? So next, the Soviet Union landed on the moon without people, of course. Then we have another one that reached, I don't know, the first successful launch of an artificial satellite. Okay. I think this one shouldn't go to the moon, but whatever. Then here's the Apollo 11 flight, which landed on the moon, and then we can go to Venus and so on. Okay, so here we are in Neptune. As you can see, we didn't scale the actual planet size, because if we did that, then at this point, all of the planets are a point or less. So we didn't want that to be lost. So we just put a disclaimer there. So this is Voyager 2, the further, no, this is Voyager 1. So this is the further space ship that the human has launched. It's outside the solar system. So, but one thing that we wanted to put here and we didn't was that the next, we wanted to put a next story here, which is the next star, which is like, this would be in here, like just outside the sun, and the next star would be like outside of the screen, probably, if we did that. So we missed that opportunity, but the idea is that to show that the scale of things is a lot bigger than one can grasp on an initial thought. So how we did that, how we built that animation and all of the things. So basically, we created a scalar component that what it does is based on a scale function from D3. I don't know if you have worked with D3, but D3 has basically a lot of helper functions to do math things, and then it had the DOM functions to manipulate the DOM. One thing that we started doing like a long time ago with JC and other guys was that we implemented, well, we used the math things from D3, but do it all of the DOM manipulation in React. So that's the idea here. So basically what this does is, based on a scale, it positions the elements in the SVG that we built. And the idea here was that I didn't want to build this thing for all of the planets and all of the objects that we put on the SVG. So I created this, and what it does basically is it scale the children's to the position that they need to be, based on the scale that we are using. Okay, to do that, to do the animation, we use framer motion, which we also use in the next project that we're going to talk. But basically, it provides a lot of helpers and utilities to animate things. Right? We were saving the old position because we needed that to do the transition. Okay, so that's it for the scalar, which is, as I said, most of the code is here. Then we have this. This is the index that again takes care of all of this part, and we have this story here also. So basically, we have the story ID, the story step, the story index, story step, and a focus item, a start and end item, and a scale. Okay. So yeah, I think this is a bit complex to explain, but the idea here is that based on the story ID, we change the domain. Okay, and the domain basically tells which part of the viewport, which is all of the solar system and the Voyager 1 and Voyager 2, we are seeing, and we define the margins of it. Okay, so basically when we change the story, we know if we have to expand or not the view. We have, again, this log events function that we use to change the story. And this is the part that changed the domain, as I was telling. Okay. At the beginning, I can show you this. So this is the story, actually. So basically, we have these story points. Okay. Based on this, we created the domain. Okay, based on the distance and the time. Actually, this is the sorry. That was the objects that appear on the sorry. So this is the domain for this one. This is the domain for the next one, and so on and so forth. And at the beginning, we didn't have that, and we were calculating the domain based on the distance for the start and end points, which were again these points. So basically, each of the elements on the visualization. Based on that, and here you can see this is the item data, which again is each of the planets, the Voyagers, and Yuri Gagarin. And we created this scalar for each of one of them, and we draw the component inside of it, which actually are just SVGs. Like the SVGs that Mariana created. That's it. At the end, JC wanted to add the constellation that you see before, below, and he added it, and I think it added a lot of visual appeal to the visualization. So we thank you for that, JC.
Yeah, Marco did all the milestone and the research of which milestones we should be showing.
I forgot to mention Marcos, but Marcos was the one that gathered all the data, and he was the one that wrote all of the stories that we put here. So big thanks to Marcos, because that was a lot of work. And that's it for this visualization. Any questions about this one or the previous visualization? Because if we talk about the other one and we come back, maybe we have trouble. Okay, no questions. Mariana, your turn.
Okay. So this will be the last one that we are currently working on now. So it's not 100% ready yet, and this is more MS. But yeah, we are going to illustrate an article about a housing market and how people immigrate in the US and how they are moving along the country from different states. Immigration reasons are main COVID and taxes and remote work and yeah, all the things that are happening now. So all these reasons seem to accelerate this moving of people from different places. And at the beginning, we started discussing also with Agustin and Alfonso how we would show, because all the article was about moving and in the US, but it didn't have a map. So the first idea was, okay, how we can visualize this in a map because it's one of the most important things that we found that was missing in the article. So we started talking about the North American map, but then realized that if we wanted to talk about percentages per state, it was difficult to visualize how if half of this state would be half of this one, it would be different amount of color spread on the visualization. So we had to think about showing this differently, and we came with this idea that we saw a reference about showing all the country in this shape of hexagons. So this way we could explore, we could divide each state in the same amount of size, same amount of pieces. And we started exploring how we could reflect percentages differently with dots or different shapes, depending on the info we wanted to show. This is more likely like a pie chart inside an X, but it was weird. So we went with this because the number of shapes we have in total is 25, so it doesn't have these magic numbers. And I think that what drove this idea was thinking about interpoling the shapes of each state into an hexagon. So it was a completely new exploration for us, especially to Alfonso, I guess, because we wanted to make this morphology from each state to turn into an hexagon shape in the same map. So with a button, like changing the state to the hexagons. And we found that it was working. So I think it's better to show this with an example, because we started deciding which information will go on each view. So we are using this map for migration movements, and the other visualization for the reasons and the incomes and the ages of people that move it from one place to another. And yeah, so I think I can lend you this. Yeah, maybe later we can talk about the shapes and everything. But yeah, Alfonso, if you want to show the final results.
Perfect. Okay, so this is the visualization for the map. Well, what you're seeing here is like the difference between the outbound and the inbound for each state. That's basically the idea here. And if we press the button, you can see this animation, and we can see the states we painted with the hexagons inside based on these reasons to migrate into the state, right? So basically for, I don't know, Texas, we have like, this should be 10% retirement. This is something that we have to work yet. How do you read this? Because this was a discussion that we have with Agustin. This is difficult to read, but it also adds a lot. Yeah, it also adds a lot of visual appeal to the visualization. So we have to play with both of those things, like easy to read, visual appeal, and basically we have to arrive at something, right? So basically each of the inner hexagons of one state equals 4% of the total population or total variable. Okay. So, well, that's the idea here, how we did this. Again, we used Framer Motion to do the animations, but Framer Motion doesn't have these transitions between two paths, actually. So basically, this is a path, and this is another path, and we wanted to animate seamlessly between both without it breaking. So we added a library called Flower. I don't know if you know the movie Flower, but I guess that's where they got the name. But the idea is that we can manipulate any path to end in another path, but it has some limitations. Like if you use a path that is like cut into multiple parts, like Hawaii, for example. Like you can see here, Hawaii has four islands, and when you go to the hexagons, they all come to the same shape. Well, we did that with a little bit of a hack, quote unquote, because the library doesn't support multiple paths. So we basically what we did is we put four shapes for Hawaii, and all of them go to the same extent. So you end with the same animation, and it looks fine. If anyone want to come with the idea or with a PR for them, or create our own open source fork for it, please go ahead, and I will greatly appreciate it, because I will probably continue using this thing. So that's for the morphing of the paths. Then we have this state. So basically, this is I don't remember which one is what. Give me 1 second, and I will. Okay, so yeah, this is the path of the state. So this is the one that converts into an hexagon or the shape of a state. We use this D, which is coming from the SVG morph that I showed before, to change in between an X path and the shape path. Then we have this group, which has some variants and transitions and animate and initial, which are part of the motion framer library, which basically tell the group to change between these any variants here. The animate is the key for the variants. So if we go here, we have X and shape. Shape is X and shape. And this is the transition that we are applying to it. Like it's gonna durate a quarter of a second, and it has a delay if we go to X's, because if we don't have that, then the blue X's start showing at the start of this animation, and that looks wrong. So we added that. We had to do some calculations to put the text in the middle of the hexagon, or the country. At the beginning, we have the names the states of the name in the center of the state shape and in the center of the X. In the end, we didn't need the name in the center of the state shape, so we removed that, but we had to do the calculation for that. Then we have this group here, which creates all of the mini hexagons that you see here. So these are created programmatically based on an XGrid. Well, they are called mini heads because they're mini. And we have this XGrid that we generate here, and some XGrid values, which are like the color to paint each of the X's. So to generate the grid, I have this here. We have one big X, which is actually this is generate X. It only takes care of a center or top left corner. Basically, I came with the idea to put it on the top left corner because the initial SVG that Mariana sent me, I had this info, but then I decided to create my X's based on the same code that I did. So in the end, I end up using the center and a size. This is trigonometry to get which of the points are where. And again, here we have some trigonometric functions to do that. And then we have the X grid. And basically, at the beginning, I came with the idea to generate all of the rows for the X grid programmatically. Basically, this is 7 rows of X's. But on the first row, you only use 2, and then you have 3 here, and so on and so forth. So at the end, what I did was just generate some X's based on the center of the first one and the quantity to the right. And this is what I came to. Like, this is first row. I only need the second X, and this is like half of the X. This is the other half. Here we have a complete X, and like just like that. So that's the idea. Basically, I constructed this grid for each of these ones because I knew the shape that the X's would have. But the X's were generated programmatically. Sorry. Well, that's most of the magic there. Well, to paint the X's, we have a accumulated value and a divisions, which is basically we have 4 or n values of percentages, like 0.4, 0.6, and what we did was just count to the first one, then count to the sum for the first one to the second one, and then count to the sum of all of the previous to the next one, and so on and so forth. And that generates a division for the colors. And that's it for it. And well, you can change the colors by changing the data. This is a work in progress yet, so we don't have the events completely added, but we are, of course, planning to add the events for the Google Analytics site. And that's it.
Okay, if you have questions, while you think about questions, if you have, I wanted to share just a last thing, if you will let me. Alfonso, sorry.
Go ahead.
This is some of the lessons I've learned from working with Alfonso, and how could I improve the code that I am delivering to him. Things, for example, well, he auto-generated all these polygons, but at the beginning I was sending him converting these shapes to paths. If you see here, like I used to have a polygon, and now with this Pathfinder, I converted to a path. And then I realized that he needed more polygons. So things to contemplate for me on my side is that when I draw these hexagons, also I had these magic numbers that didn't make any sense for his calculations. So I need to improve the way that I need to add in this creativity way of drawing, like contemplating that the code that I'm generating, he will use it, and maybe he needs to add math to it. So it's better if I have rounded numbers here. Also, that I discovered that here in SVG, in this OMG, there are ways also to move shapes to paths. So either way he needs them, I can convert him and give them the way he needs them. And also, for example, in the example of the syringe, of the vaccination, at the beginning I think I draw the vaccinations like this, like in a vertical way. So the code that this was generated was okay, like normal a rectangle with a width and a height, nothing special. But then when we decided to make it horizontal, I rotated all the drawings, and the code that is generated was with this transform matrix that didn't make any sense for the code. So another things too, that the way that I draw the SVG in Illustrator is definitely has an impact in the code that I export, and is code that he will manipulate. And the better I can deliver that code, the better for the project. For example, this magic number doesn't make any sense either. So things that I am learning in these projects are related to the code I generate with the drawings.
For that, Mariana, you had some tools like to do like flat the transform. Like what did you do? What did you do there?
To flat the transform? No, at the end, Alfonso just told me like, oh, all these strings had a transformation. I think he just rounded the numbers and converted and transformed everything. Like the project went that way, but okay. Now I have in mind that my transformations affect the code.
I think a Squash or some of these tools has a flattened functionality where you can like directly get the path and remove all the transforms.
Nice. I still need to learn some of those things. And also, I want to mention that now Lara and Facu are on board also on the project, so maybe next talk will be on them. I hope so. And if you have any ideas of things that we can make in this project, they are all welcome, as we want to have at least one per month. And the subject is open, like we don't have any limitations on that. So everyone is welcome to bring their ideas. And I think that's it. Yeah.
Yeah, as Maria said, the ideas are open. Like right now, we're working on the map one, and we are also working on some visualization of the Spotify charts. I think that's the correct name, but basically the music reproductions that occurs on Spotify per song. That's the idea. And basically, we are open to any ideas, and we want to. Well, like if everyone is on board of something, we will like to work on that. I also want to extend the call for anyone that wants to work with me on the React side of this, because, well, Mariana has Agus and Alex that they are all UX and UI side. Then we have two guys working on the part of the data, which are Marcos, Facu, and Lara. And I'm working alone on the front-end side, and sometimes I get like a lot of work. So if anyone wants to work with me, please apply on research.learninglabs.com/apply. That's all. You just send me a message, and well, we can include you in the team and work with you. And if you have any ideas to work with data or to create a nice visualization, please let us know also. That's what we do, what we want to do.
It's nice that will count as open source also. So if you apply, it's already also for open source.
Yep.
At one point.
Yeah, we want to open source this. To do that, I probably need someone to help me with the code, because we have to make it cleaner. Some parts. Okay.
This was a great talk and really nice, all the visualizations. And I love that tips, Mariana, that you were giving at the end. I think that like you should continue to share them, like even after the talk, if you see more, because they are like really useful. Do you have any question for them?
No questions. We either did it great or we did it very poorly, and no one has any questions for us.
It's awesome. One thing, guys.
Great. Go ahead, Juan.
Thank you. One thing regarding what Matthias said, yeah, I believe that since this is open source, and as I did, right, I shared like that background with the stars and everything, and it's just a way to create a commit with just some tweaks, visual tweaks that you can import if you want. And yeah, it's not that much work because you don't have to maybe fix a bug in some project, some random project on GitHub or whatever, and you can contribute to the open source community in a meaningful way.
Yes, and this will continue to be open ideas. For example, if we want to celebrate another thing about space, we can reuse these things that we have and tell another story. Even the vaccination graphics, I think we will continue to update it until the end and maybe do another revamp of this and republicate everything. But yeah, we have all this experience that we're gaining with these explorations. So maybe near to the end of the year, it would be easier for us to start coming up with ideas more fast and easily.
About that, like
yes.
When people have an idea, where should they talk to you? Like maybe in the database public channel is a good place for them.
Yes, the database channel.
Yes. Yeah, if anybody is not there, like database is a very good channel. Fabio, you wanted to tell something?
No, just wanted to say again that you did a great talk. Thank you for the talk and for the work. It looks really amazing, and share as much as you can of visualization like that. Thank you.
Thank you, Fabio.
Okay, so all ideas are welcome. If you want us to build something for the next month, June is open. Yes, so I think if there are no questions, we can just finish the talk or continue the conversation on database.
Yeah.
Yes.
Nice. Yeah, we should also share there in the channel the page, like the research page, and to all the visualizations. So like everybody that haven't seen it, they can take a look. So yes. Thanks a lot to both of you. And Sergio, you wanted to say something?
No, sorry. I just wanted to maybe say thank you for the presentation. It was great. Pretty nice way to present the information on the 3 topics covered so far.
Yeah.
Thanks.
Okay, so thanks everybody, and thanks Mariana and Alfonso. This was great.
Thank you all. Thanks for staying at the end.
Bye-bye.
Very good work.
Bye.
Bye everybody.
Thank you.
Bye.
Bye.